Hello, here's a supplemental video on just sinusoidal functions and their transformations. So let's start off with what is a sinusoidal function. Well, the key word here is sine. So it's any graph that's going to model like sine does, which is this pattern right here where it just goes through peaks and minimums. Min, max, right? It's kind of a continuous thing. So what would something like that be? Like when would we use it? Well, let's think if we're on a Ferris wheel and we want to know how far we are up after 30 seconds, right? So let's say we start down here. After 30 seconds, we're this high. So we would mark it here. And then we go another 30 seconds and maybe we're at the top. We would mark it here, right? And then as we continue going further, our height would decrease until we're back at our minimum or our starting point. Okay? So yeah, that's what a sine function is. This unit is primarily focusing on the transformations of sine functions. So what does that mean? Well, let's put it in this format first. Alright, so we have a, b, c, and d. And let's write out what a regular sine function looks like. So what something like y is equal to sine x is going to look like. Okay? So we know at 2 pi is when how long it takes us to reach a full circle or our period. So let's go like that. Start off, and then it should be 4 over like this. Do, do, do. Okay, so sine x starts at 0, and then after 2 pi on the x-axis, it's back at 0. Okay, and then our minimums here are just going to be 1 and negative. Our max is 1, our minimum is -1, and then we're in the middle at 0. So first thing we want to look at is the amplitude, or A. A just means how far it is from this point to this point, or how far we go from the middle to either the minimum or to the maximum, right? Or it's referring to top to bottom, half of that, right? So let's visualize this. Let's say we have a sinusoidal graph, but instead of our max height being 1, we want to make our max height 3. But we want to follow the same type of function, right? So we know our sinusoidals always start at 0, and then we know at this point we're going to be at our maximum, which is 3. We know we'll come back to 0, and then we know we now have to go to -3, and then back to 0, right? So we're now writing y is equal to 3 sine of x, right? And in this scenario, a is equal to 3, and that's our amplitude. So let's graph this out. Boom, boom, and like that. And probably will get it neater, use Desmos later, but it'll look something like this. Okay? So we figured out our amplitude, and of course, just like other functions, we can compress it vertically or stretch it vertically, depending on what number this is. But if the number is greater than 1, we're going to be stretching. Greater than 1 is a stretch vertically. Okay? And then less than 1, but greater than 0, and a is greater than 0, means that we're going to we're going to compress it vertically. Okay? That's our a value. B is referring to our period. Okay, what is our period? Well, period is simply the length from when we start, and let's get a different color here. So like when we start to when we come back to our starting point. Okay? And you might be asking, why is the period not this? Because we're not back at our starting point yet. We need to first go through a maximum and then a minimum before getting back to our starting point, right? So period will be the range from here to here, okay? And a normal function, how long that takes is always going to be 2 pi, right? That's going to be the equivalent to our 360 degrees, right? If we wanted to convert it and make it an even shorter one, like let's say compress it by 2, we would make our b value 2, and it would compress by a factor of 2. So what does that mean? So let's look at a graph that looks like that. So y is equal to sine of 2x, right? That means that our period now is going to go from here, and instead of being 4 squares wide, 1, 2, 3, 4, it's compressed by a factor of 2. So that means we're going to have to end here, right? And we know that means our midpoint is going to be right here, which means our maximum is halfway here, and our minimum is going to be halfway here. So we'll draw this out, and that's what that graph would look like. Y equals sine 2x. It would just compress it horizontally. We can also stretch it horizontally by making this a fraction. So if it's between 0 and 1, then it's going to stretch it horizontally or extend our period. All right. Next, we have probably our simplest transformations. So we have C. What does C mean? Well, let's go back to our base graph and erase this, because we're getting to our simpler translations. C means we're going to take this exact graph, and we'll redraw it, don't worry. I'm going to take this exact graph right here, y equals sine x, our nice starting point that we always start with. And we're going to move it either left or right. And what we call that is C is a translation. Left or right. The only tricky part about C is because it's in brackets, we have to go the opposite way, similar to how when you find the zeros of a function, you factor it and then you find the opposite sign. So if we do minus C, so let's go something like y is equal to sine x minus 3. Since it's in the bracket, we're going to make it go the opposite way. And what that means is we're going to take this whole graph, right? And we're going to have to move it 3 units to the right. So let's count. 1, 2, 3. Okay? So typically this will be in periods. So halfway through will be pi rather than 3, right? So let's make that pi instead for a clearer example, right? And we know the full graph is 2 pi, so we know that halfway through is going to be pi, so we're going to move it halfway out, right? And that's exactly what that left to right function is going to look like. Similarly, D is going to do the same thing. It's a translation, but instead of left or right, it's going to be up or down, or vertical. So C will be horizontal, and then this D value is our vertical transformation. And this one just follows conventional rules. If it's a positive, so if we have y is equal to sine x plus 1, we're going to take this graph and we're just going to move it 1 unit up, which would look like this. Okay? So, I think that covers transformations pretty in depth. A good tool to look at these in real time is going to be Desmos, so let's go in and take a look at that together. So we always start with our graph of y equals sine x. This is our base function here. Okay? So let's say we want to change the amplitude, which remember amplitude just means from the middle to our maximum value, or from the middle to our minimum value, right? And right now, if we have no number there, we just assume it's 1. But let's say we want it to now come up to 2, but remain at the same points on the x-axis. So what I need you to pay attention to here is at pi, we're at our maximum, right? And then at 2 pi, we're back in the middle, and 3 over 2 pi, we're at our minimum, right? So that's always going to happen regardless of amplitude. We can change it up, but look at how the points just move vertically, right? We're just stretching it vertically. Same as if we were to compress it. These points don't move. This is still our maximum. This is still our minimum. Their zeros will always be here when we're messing with amplitude. Right? Now we can start looking at the horizontal compression, right? And what would that look like? Well, let's see. If we want to, so our period right now is going to be 2 pi, right? If we want to make this half as or compress it by a factor of 2, see what we're doing here? Now instead of our period being 2 pi, our period is now pi. Okay? Next is our c value, which just means we're going to move it over. This one's going to be really important because y is equal to sine and y is equal to cosine of x. These graphs are very similar, but there's only one difference. There's a phase shift, a horizontal phase shift from left to right. So we know if we move it, we're going to get back to our original graph of y equals cosine. Or we can make either or, right? So let's start and make y equals sine, which is our red graph. Let's try to make it into y equals cosine. So we're at pi over 2 is where our top is, but we need to move it left to 0. Okay, so we're going to move our whole graph to the left, and if we're going left, we're adding, and we know how much do we have to move it? Pi over 2. So we're going to do plus pi over 2. And now our graphs are overlapping. We have the exact same graph with a phase shift. And this is where trig identities come from, because we have these transformations. Just like if we were to use, I believe we could do minus pi over 2. And it would be exactly the same to y equals sine x, right? So all that's doing is just moving it left to right. Our last transformation is moving it up or down, right? So if we want to move a unit up, or 2 units up, or maybe 1 unit down, we have our -1. All right, thank you.